Hi, geometry students. Today we're going to talk about the intersection between points, lines, and planes. What's an intersection? An intersection is where two things overlap or they cross each other or touch each other. So ask yourself, when two lines intersect, what is their intersection? In other words, when they cross, where do they meet or overlap? Is there anything that exists on both of those lines at the same time? If you draw two lines, you see that intersecting lines, in this case line AB and line CD, they intersect in a single point. In this case, they intersect in point O. And that's actually one of our postulates. If two distinct lines intersect, they intersect in exactly one point. And you can think about why that makes sense, because we defined a line as a perfectly straight, as something that's perfectly straight extending in opposite directions. And so only if it was a curve would it loop around and intersect a second time. And it's not, because we define lines as being perfectly straight. So if two distinct lines intersect, their intersection is 1 point, exactly 1 point. All right, what about two planes? In order to visualize this, you could look at two walls in your house. Where did the two walls intersect? What does their intersection look like? You could also pick up a box that you have around, a soda can box, if you like, and to try to visualize this. Now remember, planes are infinite in all directions. So this side of the box isn't really a plane, it's just like a shape, but we are imagining that it's a plane. We're imagining it extends infinitely in this direction, infinitely in this direction, infinitely in this direction, infinitely in this direction. So if this is one infinite plane, and let's say this is the second infinite plane, pretend it also extends infinitely in all directions, then this plane and this plane intersect in this edge. But because the planes are infinite, their intersection is infinite. So in other words, a line. And so here's an illustration to also help see. Here's representing a purple plane, pretending it goes on for all of infinity, and a red plane, and their intersection is this line CD. And of course, we have a postulate that states that if two distinct planes intersect, they will intersect in exactly one line. So let's practice this skill. Now, when you look at a diagram like this, where is the plane that holds, where is plane BCE? You may want to use your pencil and shade in B, C, E. And once you shade in those points, you see the plane that catches them all. In this case, is on the top. Where is plane ABC? You might want to shade A, B, C with your pencil, and then you see that it's this front plane. And so let's do this. Let me get a pen here. So B, C, E is this top plane, and ABC, ABC is this front plane. And so you can see that they intersect in this edge BC. So now I want you to take a minute and you find the intersection of these two planes. Pause and do that on your own paper and see if you can come up with the intersection of these two planes, and then press play for the answer. So ADF is on the bottom, and CDF is on the side and the bottom planes. The side and the bottom planes intersect in this edge, DF. Okay, let's do one more practice. Using the same cube, let's find where plane CEF intersects with plane CDA. So CEF is this side, and CDA is the front, And the side and the front intersect in this edge right here. But because the sides represent planes, the intersection of the planes is the line. Now you could also work backwards. Somebody could ask you, well, if I start with line BF, which two planes intersect in BF? And we know that through any line there are infinite planes, but let's just pick two of them. The first thing I would do is shade that line, and then you know that both planes will have these 2 points in them. So BFE and BFC. Another way to name BFC would be BFG. Another way to name this, any 3 points will name the plane. All right, now take a minute and find the intersection. Pause the video and write down the planes that intersect in HG. So HG is this front edge here. So this plane and this plane, the bottom and the front row. So the front and that bottom plane would create that intersection. Reminder that any 3 points will lie in at least one plane, and 3 non-collinear points lie in exactly one plane. So 3 points are always coplanar. With that in mind, where is plane EAG? Pause the video and think about that, and then press play. There's a diagonal plane that goes through EA and G that you could shade in that way. Now, lines that intersect in one point, and a special case of intersecting lines that we're going to be talking about later in this course are perpendicular lines. Perpendicular lines are 2 lines that intersect in a point, just like any intersecting lines, but they intersect in such a way as to create a 90-degree angle. And here's the symbol for perpendicular lines, which we'll be talking more about throughout the course. Now, there are a couple cases of lines that never intersect. Lines that never intersect, but they are coplanar. They live in the same plane, but they never intersect. Those are parallel lines, and we're going to be doing some work with parallel lines. Other lines that never intersect are non-coplanar lines, and lines that are not even in the same plane are called skew lines. So pause and answer this question, and then press play for the answer. This is a 3-dimensional drawing, so this is representing a plane, and this is representing a line that punctures the plane and then shoots out the bottom of that plane. So where do SQ and plane X intersect? Point R. All right, now pause the video and answer this question, and then press play for the answer. What is the intersection between RT, this line, and TU, this line? These 2 lines intersect in point T. And that does it for this video. So I will leave you with this cute picture of a puppy. Have a great day.